come up to that adder. We have actually covered that half and full adder, and we were discussing about the full adder making use of with two half adder, and I think we have to derive that derivation. You can go through that PDF. Already that PDF have that derivation, that how we are going to convert that two half adders into one full adder, right? So for that carry out we were going to derive that derivation in previous lecture. This was the last lecture point. Okay, now I think all of you now seen about the syllabus. There is one syllabus PDF was sent by Kadam madam. Have you gone through that? Have you seen some change in the syllabus? That unit 1 is logic families, unit 2 is combinational circuits, and again there is one third unit is also combinational circuit, right? Actually this was as per previous syllabus, this content was in unit number 1, but now as per syllabus this one is unit 1 and this one is divided into 2 units. This is second and this one is third. Okay, now, and as we know that INSEM will be on unit 1 and 2, so we are going to cover what remaining content is of combinational circuit, that is unit number 2. In unit number 2, if you see the syllabus, then you will got that it content consists of standard representation, swap and pause, their interconvergence, swap to pause, pause to swap, and after that they have gone for the combinational logic, and in that combinational logic they have started with the K-map, already we have covered. At the last point they have gone for the Queen-McKelsey method also, that we have also covered all these 4 topics. Now remaining is about the arithmetic circuits in the design examples, that we are going on with this point. Already we have covered the adders, now we are going to cover today subtractors. Now after this one is asking to design that code converters. So after this subtractor we will go for the code converters, and then unit 3 will get start, but our unit 1 is remaining, so we will go for the unit 1 after this one. So by today we will complete the subtractor. Adder is already covered, so after subtractor we will go for the code converters, and then after revising all these contents, so we will go for the unit number 1, that is logic families. Fine. Now today we are going to start the subtractor. Now subtractor, as what we have seen for the adder, the subtractor, this subtractor is one digital combinational logic circuit which performs subtraction of bits, and that bits will be in the form of binary. See in the bracket in that PDF or notes I have written the binary. That means that subtractor is performing the subtraction or computes the subtraction operation on that binary bits. Now that means there is again one first subtractor is there, that is nothing but half subtractor, as what we have seen for the half adder and full adder. So similar will be here. So at the starting we are going for the half subtractor. Can anyone tell me what is meant by half subtractor? Yes. How many inputs will be there? Yes, there will be 2. That means the subtractor, that means a combinational logic circuit that computes the subtraction operation on 2 binary digits. Suppose if this is A and B, these are the inputs, that is binary digits, and it provides, obviously, what will be the result of subtraction? What is the difference or difference between these two binary bits? That will be the result. And if there is a carry, now here we are meant by carry, that is nothing but borrow. Am I right? Is it clear to all of you? Now, before starting it, as we have gone for the rules for binary addition, and that already you know about the rules of binary subtraction. So binary subtraction rules, I think already you know about this one, but for this clarification I am just going through them. What will be the 0 plus 0, 0 minus 0, that is 0 in binary. 0 minus 1 is 1, that is difference is 1, and the borrow is also 1, right? This is borrow and this one is the difference. 1 minus 1 is 0, and last one, that is 1 minus 0, the difference is of 1, right? Now if you observe here, for these two cases, some of students get confused here of these two cases. When this first bit is larger, from which we are going to subtract, if that bit, that is a bit, is 1 and this bit is 0, that means this is larger as compared to the second bit, so that time the difference will be 1. And if a or first bit is smaller from which we are subtracting, then we will get the result that difference is of 1 and first bit is not larger than the second one, that means second one is larger, so that's why the borrow is also of 1, right? Because this is a negative result, and that's why we have to represent it by a borrow. I think already these know about you. Now, so this one is about the half subtractor. Now obviously we know that we have to design these logic circuits, and we know that what is the sequence. From functional we are going for the truth table, from truth table we are going for K-map, from that K-map we are finding out the Boolean equations of functions, and from that we are designing or implementing that circuit, that is logic circuit we will going to design. So we are here. Now we have to go for the truth table. Obviously, how many inputs are there? 2, that is A and B. How many outputs are there? 2. First one is difference, that is subtraction, and second one is borrow. Now for understanding purpose, I am writing this as a C0, as whatever we have written into our adders, so that you will not get confused. So I am writing here this borrow as a C0, that is C out, that is borrow here. Don't get confused. Now, so we will get here, there are 2 inputs, so what will the combinations, maximum combinations will be possible? 0 0, 0 1, 1 0, 1 1. Now as we know that already we have just seen the rules, so we will find out what will be the outputs. These 2 columns will be there. So 0 minus 0, first case, 0 minus 0, result is 0, difference is 0, obviously borrow will be 0, right? Second one, 0 minus 1. Now see, now a bit, a binary bit is smaller as compared to the second one, so obviously there is a difference between them is of 1, right? And that's why, see, this first bit is smaller and from which we are subtracting the second bit, so this is smaller, so that's why negative result or borrow will be generated, right? So that's why difference is of 1 and borrow, or we can say carry, is generated here, okay, for your simplification purpose. Next, 1 minus 0, this case 1 minus 0 is difference is of 1, and this one is larger, so that's why there is no borrow will be or carry will be generated, right? So difference is of 1 and this borrow is 0. Next, last case, 1 minus 1, What is the difference? Difference is 0, right? So, and this bit is not smaller than the second one, so that's why no carry or borrow will be generated, right? So that's why 0 with 0, 0 difference and 0 borrow, or we can say carry, right? So this one is the truth table for your half subtractor. Is there is any problem? I don't think there is a problem. Now for your understanding purpose, to draw the KMF in the next step, I am writing here that two last columns, that is difference and that borrow, 0 1 0 0, right? Now I am going to find out what will be the minimal equations using the KMF. So how many input variables are there? A and B, 2. How many cells will be there in KMap? Obviously 4. What was the input? A and B is the input, and we are find outing the equation of difference, right? This one is 0 1 2 3 number of location cells, right? Now for your difference, this is the column 0 1 1 0. So 0 1, I am not writing here this 0 because you will get confused. So 0 1 1 0, right? Now tell me, what is possible here? Is the chord is possible? No, because only two ones are there. So we are going for find outing is there is pair grouping is possible? No, again. I think this one is similar to your that which table? Okay, very good, XOR. So there is a single bit is possible, no grouping is possible because these are diagonal, right? These are not actually in vertical or horizontal manner, so that's why there is single bits are possible. So for this first bit, for difference we are writing the equation for this first bit A B bar, so A dot B bar. For the second bit, what will be the equation? A bar B. So from this equation is seems same that for the XOR gate, so that's why I am writing here A XOR with B. Already I have proved this, right? So that's why I am writing here that D for difference of half adder, I got the equation A XOR with B, right? Now we'll go for find outing the second output equation, and that second output was borrow. That is, we have decided to define it by a C0. Now for that I have to draw again one KMap. Obviously there are two variables, so 4 cells, 0 1 2 3. Now check out this column 0 1 0 0 0 1 0 0, right? This one is A B 0 1 0 1, right? Now there is only one bit is there, so that's why no grouping is possible. And what will be the equation of this borrow or carry out? Yes, A bar dot B, right? Now from these two equations we are going to design that logic circuit or implement that logic circuit. So there are two gates are required. First, that means for half subtractor, two inputs are there, A B, two outputs. First one is difference, second is carry out or borrow. Now I am going to design that circuit using these two equations. XOR gate, this one is A B, this one is a difference A XOR with B. Second one, that means for second output we required A bar dot B. So this first one A, this one is B. I have to give it to your one AND gate, but before that this A must be barred. So right, this one is your and this one is your one not or inverter, you can say, right? So you will get here A bar, this one is B. So here you will get the borrow or different or carry out. For this simplification purpose we have noted it as A bar dot B. Is there is any problem is there up till? I don't think so. Yes, this one is very simple. So this one is completion of your half subtractor. Now we will go for full subtractor. Now can anyone, I think from your side, tell me what is mean by full subtractor? See, try to say in the form of definition, so you will not get forget when the question is asked in MCQ form or in competitive exams. They are asked with technical words, so that you will get confused. So this is full subtractor. Full subtractor is a circuit, that is combinational logic circuit, that it having which computes the difference of subtraction between three binary input, right? So A, B, and suppose I am now noting it as a, if you required here you can write here B in, that is borrow in. So there are three inputs. This is full subtractor, so more than the 2 bit, that is 3 input bits are there, and the result will be again it will give the difference between all these 3 bits, and obviously there will be borrow out. So this is your borrow out. For simplification purpose you can write it as a C0 also, because this is somewhat confusing. A, B is input, and we have taken again B in as a input, and we are saying B0 as output. Whatever you required, this one is simple, so you can note it as you wish. Okay, but don't get confused. So this one is your full subtractor. Now from this we have to go for truth table, right? So I am directly drawing here. The truth table is of actually 7 combinations will be there, because now inputs are A, B and B in. Am I right? I think yes. There is no response from your side. Should I write this as a C0? So you will not get confused. So there are 3 inputs A, B, and third one is initial borrow, right? So in same manner, now that I have not taken here, that what was the disadvantage of half adder? Yes, that we cannot subtract or we cannot consider the initial borrow, right? So this was the disadvantage, and that is covered in this full adder. So what will be the combinations will be possible? Maximum 7 combinations: 0, 0, 0, 0, 0, 1, 0, 1, 0, 2, 3, 4, 5, 6, and last one is 7. Yes, now we will go to find out these 2 columns, what will be the outputs for this, and then we will go for the find outing the equations for difference and borrow out with the help of KMF. Now for this first case, 0 minus 0 minus 0, 0 minus 0 is 0, 0 minus 0 is 0. So obviously these all are 0, so borrow or carry out is also 0. So I am writing here difference is 0, borrow or carry is also 0. Second case, 0 minus 0 minus 1, right? Now we have to perform the subtraction. This 0 minus 0 is 0, 0 minus 1, now A minus B, and A is smaller. So obviously we know that borrow will be generated. So 0 minus 1, what is the difference? Difference is of 1, and this A is smaller, so that's why borrow will be generated, right? So difference is of 1 and borrow is also generated, right, for this case. Now next one, that is 0 minus 1 minus 0. So 0 minus 1 minus 0. Tell me, 0 minus 1 is, what is the difference? Difference किती बीट मध्ये? 1. आणि A बीट छोटा आहे का? Yes. So borrow will be, right? So that's why directly I am writing here borrow. Now 1 minus 0, yes, difference is of 1 and borrow is also generated. Have you got this? Most of students will get confused. Within a just minute I will repeat this for you. See here, 0 1 0, 0 minus 1, difference is of 1 and this one is smaller, so that's why borrow is generated. 1 minus 0, difference is of 1, right? So for this case, difference is of 1, borrow is also 1. Next case, 0 minus 1 minus 1, 0 minus 1 minus 1, difference 0 minus 1 is of 1, right? Now this is small, so that's why borrow will be generated. Now 1 minus 1, difference is of, difference किती है? 0. So for this case, a difference is of 0 and borrow will be generated. I think there is no problem, as I am saying clearly to all of you. This one is very simple. If you quite keep attention here. 1, next case 0 0. Now 1 minus 0, what is the difference? 1. But now A is greater as compared to B, so borrow will be not generated. 1 minus 0, difference is of 1, right? So difference is of 1, but borrow is not generated in this case, right? Next one, for this one, 1 minus 0 minus 1. Tell me the difference. Difference of these two bits is 1 minus 0 is 1. Obviously this is greater, no borrow is generated. 1 minus 1, difference is of 0. So these are the some typical cases, and most of students will get confused. They are in overconfidence, and during the exam they will get confused how it is possible. I know this will happen, but this requires a practice. So it will be this is very simpler, but it requires the practice. 1 minus 1 is again 0. 0 minus 0 is 0. Last one case, 1 minus 1 minus 1. Let us check out. 1 minus 1, 0. 0 minus 1. Now this is A and this one is B. 0 minus 1 is, difference is of 1, and this is A. A is smaller than B, so that's why borrow is 1. If there is any problem to all of you, tell me please. I will clear you. Yes? Any one of you? Reply me fast. I think all of you have cleared this, right? Hello? Hello? Is it visible? Hello, reply. Sujay?